Okay, so let's pause there on heating and cooling and say, well, how does this all relate back to all this building performance analysis stuff? Because it really, yeah, it may be sort of confusing how all these things start working together. And in some ways, this space and our analysis for heating and cooling is independent of that. We're making some pretty gross assumptions there. But in other ways, it's related, because what's actually happening is we are going through and using kind of the boundaries of the walls that you put in place and some thermal properties. Okay, but yeah, they kind of get used in slightly different ways. Let me see if I can sort of illustrate that and make it clearer. Okay, so we have this basic space, and you have your basic spaces that you've been designing. Okay, and if we want to go ahead and do the same sort of thermal analysis for the spaces, really understand the overall building performance and really where the opportunities are to go through and improve the building energy use that ultimately help us kind of do a better job of sizing these systems. Here's how you can approach it within Revit. So that is, it all starts out here. We got this basic, like a little 2-room building that has some space in it, or has some rooms in it. Okay. As we go ahead and start thinking about trying to do building performance analysis on this, it really comes down to the thermal properties of the materials you actually put in there. Let's stop and take a look at that. If you go through and choose any of the walls, for example, my exterior wall, you'll see that I have chosen some sort of type. It's a basic wall with exterior brick on metal studs. And if I take a look at the type properties for that, you actually see it does have some sort of assumption about the thermal mass as well as the thermal resistance. So it's actually a pretty hefty wall stuff. R54 wall. Definitely kind of a big old chunky wall. And where it's getting that value from is it's really just the materials themselves and the thickness of the materials. So if I go in and take a look at the structure of the wall, we have all these different layers of the wall, and for each of those different layers, all the materials are associated with some sort of thermal values. So for example, the common brick is a sort of material. It has all these visual properties, but it also has thermal properties. So it has a certain thermal conductivity and a density, and using this we can basically go through and figure out, for every inch of wall, how much R value it's adding in there. Let me go ahead and cancel out of that. So for example, right now I have this single layer of brick. It's about 3 5/8 thick. If I went through and doubled that up, if I actually went through and had 2 layers of brick, okay, what would that be? That would be like 7 1/4, something like that. 10/8, 2/8, yeah. If I change that to 7 1/4 to indicate a double layer, or actually what I should probably do is, I'll leave it at that. Let me just add another layer to it. I kind of like to keep things very, very visible about what I have in mind. Okay, beautiful. And I say OK. What should happen is, didn't actually change very much. It looks like the brick is not really providing us with very much of an insulative value, which actually sort of makes sense. It has kind of good thermal mass, but it's not a very great insulator in terms of what's going on. I'm going to delete that back out. If I change to a different material, if, for example, I switch instead of brick on material on metal studs to, oh, what else do we have on here? Not too much CMU on metal studs. That does like an R53. Or if I go through and try and create some similar structure, like what's a common wall, like what are some wall structures you're thinking about right now relative to your own walls, like in your buildings? Like, so anyone have like on your building with the what you think the exterior walls would be made out of? Okay. Amy, do you have an idea? What do you got?
Oh, I was trying to put like an exterior like shading thing.
So, how much is for the wall layer itself? Like how much insulation you can put in your building, or like in your walls? Like how thick is the wall going to be?
I think it's like 8 inches.
Okay, about 8 inches?
Yeah.
I'm going to fill it with bad insulation, or put some sort of foam in there, or what do you have in mind?
Yeah, I would think maybe like concrete or some insulation.
Okay, great. Let's try that. Let us try that, just to kind of get a sense of this. So, I'm just going to go ahead and duplicate this, and we're going to say this. That's going to be Amy's wall. From here on out, forever to be known as Amy's wall. And I'll get rid of some of these layers. So we're going to put some like cast in place concrete here. Okay, about how thick is your concrete?
Maybe 6 inches.
Okay, that's cool. Let me get rid of some of these other things. Okay, do you have any plywood on the outside? You probably don't need plywood on the outside if you have all that concrete in there. We might have a little infiltration barrier. Do you want to put any air in there between you and the insulation, or do you want to? Is your insulation going to be on the inside or the outside? How about that?
The outside.
Okay, super. And okay, let me go ahead and put some insulation in here. You got some sort of like rigid insulation, or what do you have in mind?
Not sure.
Let's see what we got in here. It's like a rigid fiberboard, fiberglass. I got some other ones down in here that aren't even in here.
The rigid one's probably fine.
What's that?
The rigid one's probably fine.
Let's go for that. Okay, let's see what it's got. It's got some sort of thermal properties in there. Looks like it's actually pretty good in terms of its, it seems like it's very resistive. Okay, so let's go ahead and do this. And for right now, let's put in a real thin layer, like only an inch thick. We'll change that in a little bit. I'll keep this little 1/2 inch of gypsum wallboard on the inside. You'll probably have something like that. Or no, you're gonna have like a rough concrete wall on the inside. What do you have in mind?
Yeah.
Great. Okay, let's take that out. So concrete, just a little bit of, that's not right with there. Rigid insulation. Okay, we'll say okay, let's make that real skinny, like an inch thick. Just to kind of test it. Okay, so far we only got an R9 wall. For all that beautiful concrete, it's fantastic as a thermal mass, but it's not so good as an insulator. Okay, so seems like we need more insulation. How much insulation do you think? Let's try. Sure. Let's go ahead and let's put 4 inches on the outside. 4 feet. That might be a little bit much. See how good that does. We'll get some sense of this. 4 inches got us up to 21. That's not too bad. R19 is kind of a very standard sort of wall for the prescriptive standard, so that would probably do it. What kind of siding material do you have on the outside of this thing?
On the outside of the
Yeah, what's the actual exterior finish? What's going to be out there? Some sort of wood paneling? Super. Okay, so I'll change that to be like a finish layer and call it, let's see what we got in here. Siding, clapboard. Let's see if we got some sort of panel. Metal panels. We might have to go through and make up our own material. If we think it's sort of wood, I can go with something like plywood in there for right now just to get the thermal properties, and we'll figure out what the actual thermal, or how to articulate it a little bit better. What you can do sometimes is like, oh, even here is, oh, hang on. I'll leave it at that. Call it that. Oops. Make it an inch thick. Okay. There it is. So we got this wall. This is basically a 12-inch wall, and it has these thermal properties of somewhere around R22. Super. Okay, so what we've just done is we've changed that one wall to go ahead and have those thermal properties. See if I can go ahead and show this a little bit better. So that's my wall. If I want to go through and change these other ones to actually match that, I can do that. Or if I was really good about this, I might just go ahead and zoom to fit. Do a little tab. Man, I can't really do it that way. I was going to do my famous tab to select the entire chain of walls, but it doesn't look like it's going to cooperate with me today. So I think I've broken the chain. Amy's wall there. Okay. Beautiful. How about this roof? Let's take a look at what these roof properties are. As a basic old generic 12-inch roof, let's see what it's got going for it. Looks like it doesn't have any thermal properties, so we're going to need to give it some thermal properties too. Okay. If we choose from amongst the various options in here, looks like we don't have very many options, so let's duplicate something in here. I'm going to call it a wood frame roof. And again, we can go through here and put in something that we think is going to kind of capture the essence of really what we're going to put up in that roof. So we could put it with bad insulation, we could put the rigid insulation in there, whatever you really want to. And I'm going to put bad insulation in there. That's what we often do for little wood frame roofs. Well, no, maybe that's not the best assumption. Maybe we could do it with the concrete and the... let's change it that way. We'll kind of keep it more like what you have in mind. Do you have a sense on your roof, Amy, what you want? Not really? Okay, let's make a concrete roof. We'll do something like that. Again, maybe 6 inches like that. But we'll put some more insulation on here because we might actually want to put some sort of green roof up there eventually or something like that. So I'll put some more rigid insulation in here. Maybe that's 6 inches worth later. We'll figure that out later. You can see now what the R value of the wall or roof is right now. It's about 25. We might need to put in some more in there in terms of what's going on. Or we can put in some insulation on the other side too, on the underside of the roof. I'll leave it at that for now. I should rename that. Okay. So we have now dictated some thermal properties that we would like to use because in your model, you want to go through and put all these properties in there, have the model be an accurate reflection so that that can actually carry forward into the analysis. Okay, to make the real properties that you've put in place work, we're going to go back to the floor plan, and as opposed to spaces, which are really more sort of a conceptual notion, we're going to put rooms in. So rooms and spaces, again, they're so similar, it's a little bit confusing about how to use them, but to get the true energy analysis using the building properties, it likes rooms as opposed to spaces. And there may actually be a big overlap. In fact, what you'll see here is in my little space, I have a room. Go and make it like 10 feet tall also, just so it can be to the top. And I also have a room to match this space over here. And I think it's there. There it is. That's the space. There is the room. Again, I'm going to make it 10 feet tall, so it's sure to go ahead and hit the roof. Otherwise, it'll be unenclosed. Okay, so now I have basically rooms matching the spaces and the real thermal properties. So here's what you can do at this point in terms of really going through and doing that analysis. So, got your thermal properties, got your room, you have your location, you're ready to go. And how we analyze that is back under the Analyze tab, as opposed to just looking at the reports for the heating and ventilating and cooling, we go over to the energy analysis. And within there, we're going to do a couple of different things. A big choice right up front we have is really, are we going to use conceptual energy mode, conceptual mass mode, or are we going to do the true building properties, the building elements? Okay, and we're going to do building elements now. So the idea is early on, when it's just a conceptual mass and kind of a form, you can give thermal properties to these surfaces. Now you've got the real building elements in there, and you'd like them to actually use that. And use the true thermal properties of your windows, and the true values, the shading elements that are being provided. All those actually being the true values. So we'll switch that over to building element mode. Energy settings, this should look fairly familiar. In terms of it's the office, it's in Stanford, California, that's okay. In terms of the export category though, we're going to change it to be buildings as opposed to, or rooms as opposed to spaces. And let's talk about why that is. In the spaces mode, you have this whole idea of building construction, and there's these generic classes of building surfaces and the thermal properties that we want to associate with them. If I change that over to rooms instead, okay, it's actually going to say include the thermal properties, and that lets us actually, for the detailed modeling you've done, include specifically those values. Okay, so that's the big difference, is if it's spaces, as we did before, okay, you need to go ahead and put in just some high-level values for what you think the building construction properties are going to be. But if you actually change it over to rooms, then room by room, element by element, you can go through and get the very detailed thermal properties and carry them. Okay, that's pretty much enough to get ourselves going. Okay, we can again get to sort of what the system is, but I'll leave it at that for right now. Say okay. Okay, we are ready now to go through and do the analysis. And when you are ready to do the analysis, what we will do is, got to sign in. We sign in. So again, if you haven't used this before, this is the same ID you use to download the software. I can say, sign in is complete. Let me go through now and run the energy simulation. So it's going to say, I need to create an energy model. I'll say, go ahead and do that. Say okay. It's basically going to go ahead and send some information off to the cloud now, and it's going to be doing some basically computing. So yeah, I'll do that. Session 15, start analysis. Continue that. And let it go ahead and get going with the simulation. So as it goes off and does the simulation, we'll see that we can kind of take a look at the results here within Revit. Okay. We can also go ahead and start exporting the results to other platforms. And we'll get to that in just a second. Let's see what's going to do its thing for a second. So it's starting, it's sitting there at 0%. Let's see, go a little bit further. Looks like it's off doing something. Okay, let us take a look at how you actually look at the results and where you can go with all this. So it's actually off there cooking away in the background. I know it's not done yet. It's going to be a fairly quick analysis, but it's probably not done yet. There's this option under the energy analysis that says results and compare. Let's start there. And even as this one's cooking away, we can take a look at, the way I analyzed it last week, because it'll give us a pretty good sense of really the types of results you get out of it. In terms of what's happening out here, I think it's not too bad. It's at 62% right now. 83%? Maybe we'll wait for a second. It's going to get pretty close. There's really a lot of different projects out here that we've run some testing on. 98%. Ooh, it's getting so close. I'm tempted to wait. It's always that last 2% that kills you, though. You should never wait for the last 2%. It sort of begs the question, 2% of what? It's clearly not your, looks like it's done. Notice it actually gave me a little announcement over there to tell me that it was done. Okay, so let's take a look at it. It's over here. So here's what we got going. Here's our little building and what's coming out of the analysis. So it's a lot of the same data. Let me start with this. Basically, all of these calculations are based on very similar analytical models. They vary a little bit around the edges, but in a lot of ways they're very, very similar. So this whole notion of surfaces and heat flowing in and out, it's very common to all these different models. So each of these, you get some very similar results. They'll be different a little bit in terms of the precise numbers that are reported, because everyone is a little bit different about the assumptions you plug in. But hopefully, comparatively, you'll get similar answers. So the types of insights you get from one analysis should be fairly similar to the types of insights you're getting from some other analysis. It should hopefully be giving you similar insights. Okay, so in terms of this analysis, let's take a look at what you got. So there is some overall stuff in here about the life cycle energy use cost and really what's predicted in terms of over 30 years in terms of how much energy we're using. And overall, this whole notion of the energy use intensity, a really good high-level metric to sort of evaluate one building versus another. That's just how much energy you're using per square foot, okay, per year. So that's actually a really good high-level metric. Other things that it's actually showing us, though, are some of the kind of interesting potential this building has. For example, in this diagram right here, you see a little about sort of the energy being used. You can sort of see there's some fuel consumption and some energy consumption, the kind of dark orange and the lighter orange. Okay, looks like we're using a whole lot of electricity, not so much fuel right now. So that's going to tell me something about just really where the energy is going. It's probably going into lighting and power and cooling. This building doesn't really have much of a heat demand right now. In Palo Alto, that's not surprising. It's a fairly well-insulated building in a very mild climate. It probably has pretty good fuel consumption, but we still do have some electricity going on. We can think about what we can do to mitigate that. And if we have a lot of cooling load, how we can put some shades on the windows or do something just kind of control the amount of cooling that we're going to have to provide. You'll see also there's this very interesting band over here, energy generation potential. You'll see that this building is actually considered to have a very high photovoltaic potential. So if we put photovoltaic panels on there, if we're going to use 31 tons in cooling, it actually thinks we could probably come up with like 59 tons worth of photovoltaic power off of the roof, which is actually pretty interesting. We'll take a look at that in more detail. So this could actually be a net positive building as opposed to a net negative building. It's a very simple building right now, but it is possible to get there. And in terms of the potential, you'll see there's some potential from different sizes of photovoltaic systems. There's also some potential about wind turbine. In this case, it's not reporting much in terms of wind turbine potential. So I got to think about why that is. As you scroll on down this list, you start to see sort of where it thinks it's using, for example, the electricity. Most of the electricity is actually just being consumed by miscellaneous equipment. That's equipment that's assumed to be in this office space. A lot's going for lighting. It turns out it really isn't all that much for cooling even. Okay. But there's different loads. This graph is sort of an interesting one. This sort of tells us, based on all the options that it knows about, really, where does it think that you can make the biggest potential in terms of improving the energy? So in terms of the wall insulation, the roof insulation, there's not much potential. It actually looks pretty good in terms of these R38 walls, the R19 walls. Doesn't think you have much room to improve there. It thinks in terms of the assumptions, the window glazing has some potential. There's a little bit of room to move the needle there by kind of improving that material. Yeah, we can change it somewhat by the lighting efficiency. We can change it by changing the plug load efficiency. But looking at this graph of all the things that you might want to concentrate on, your window glazing is probably one of the most opportune things to go through and take a look at right now. Okay, that might be, from a shading perspective. That might also be from just a conductance perspective. It could be either way. You can start to see in terms of the heating and cooling loads where we're losing or gaining things. So on the cooling side right now, you can see that we have a lot of window solar. We have a little bit of window conductive, but very little actually. Actually, here it is. During the winter months, what's actually happening is those windows which are allowing cool to come in are actually helping keep the space cool. I think what's basically happening in this very closed box is that we have a lot of heat being generated, not a whole lot of relief for the heat. Okay, so it's actually working to our advantage there. You can get to sort of what the fuel consumption is, and you can consume the data at this level. But if you want to dig in a little bit deeper, let's talk about that. So if you want to get a little bit further, you can go through doing an export of this data, and you can export it into a number of file formats you might be interested in. For example, if you like to use Energy Plus, you can take it out as an IDF file. If you like to use eQuest, you can take it out as an INP file. Is that right, Amy? INP takes it over there? Great. So what that'll do is allow you to use the modeling tool as the generator of the different surfaces and give you some initial assumptions that will come through the INP file that you can then start tweaking around inside of eQuest to go through and do that. Now, when you do it this way, as best we can tell, you don't get a lot of the wizard functionality unless you create different design options and vary things very quickly. Okay, but you do have the ability to go through and take it out there, and hopefully you get very similar results from doing something like that. Okay. Another thing you can do with this data, though, that I want to tell you about is, okay, we can actually go through and open it in Green Building Studio and get a little bit more detail. Let me show you what that's all about. So this is really a high-level summary of the results. But what Green Building Studio is a web interface that really gives you access to all the detailed information that's behind this report. So we can see that there is a base run of this job, okay, that has this energy use intensity of 74.1. It looks like there's some other ones that actually have lower energy use intensities based on different sets of assumptions. What it went through and did was actually varied a lot of assumptions to come up with a lot of different variations. So it, for example, even has one that has to do with, what is it, some ultra high efficiency skylights and glass. They could actually get it down to even 65.5, but there's all these different variations of different types of glazing, different assumptions about what the plug loads is, different assumptions about the orientation of the building. So even doing something like just reorienting the building a little might make a big difference in terms of the consumption. So let me pop that back out again, though. See if I can get back to my base run. And take a look at what's actually shown in there. There's all this detailed information in here about, what the CO2 emissions are, what the energy is, really use of both fuel and electricity and things like that. So there's a lot of interesting information here. But some of the ones that I think are probably the most interesting are actually floating around down in these charts. Let me kind of show you what some of those do. For example, there's this whole notion of the photovoltaic potential. You may be wondering about the photovoltaic potential or the wind ventilation or even the natural ventilation potential in terms of what it actually thinks is possible to go through and change things. So photovoltaic, let me take a look at that one. We'll get to this when we start talking about electrical systems. But if we looked at all the different surfaces on that building, and we thought about a payback period in terms of if we put high efficiency solar panels on there and how long we would allow the payback period to be in terms of generating enough electricity to offset the cost of actually putting panels on there, we can set different thresholds here, and based upon those thresholds about what we're willing to live with as a payback period, have some materials that are going to, or some surfaces that are opportune or less opportune. So you'll see, for example, the flat roof surface, it's going to pay off in about 32.7 years. Okay, some of these exterior walls, they're not going to pay off for close to 40 years or even 60 years, or this exterior wall here, which I'm betting is on the north side. It wouldn't do any good to put solar panels on that wall because it's just not going to pay off like anytime soon. So what this allows us to do is actually go through and identify the surfaces that really have the best payoff potential. And even in here, if you say that you have, a specific threshold that you want to use, hang on, maximum payback period. If I say that this thing basically has to pay off in 33 years, it'll go through and show us, what is it? In 33 years, well, looks like it's not getting anything there. $35 it was. All the surfaces that are currently green right now, they are the ones that we should consider for going through and putting that sort of photovoltaic potential on there. Okay, some of the other things that are coming out of Green Building Studio, and I'll wrap up with this, that are available are, there's things like lead daylight. We'll talk about that in terms of trying to achieve a certain minimum amount of daylight, in each of the different interior spaces and whether we are achieving that. It looks like, what's happening in here? We're actually doing okay relative to the big workroom right now, partly because I went through and put all that kind of glazing on the front of it. In terms of that other room, that storeroom, though, it's basically got 0% right now. So that's not going to work. So this is actually going to qualify because the basic criteria is if over 75% of the regularly occupied spaces provide at least 2%, we qualify for the LEED daylight credit. Here, 84% of our building is. So it's actually doing okay. The final one I want to point out to you here is the whole water usage. This is actually sort of tied into somehow your project in that we actually have, based upon this building and just the total amount of roof catchment area, a certain amount of rainfall that's going to come in the Stanford area and a certain amount of area to collect it. So we can actually think about really how we go through and have the ability to go through and use rainwater. So, for example, right now, this isn't actually doing very much with us right now. We know that in the Palo Alto area, it's reporting that 51.19 inches of rainfall are coming. We have about 3,000 square feet. So if we go through and say that we want to turn on rainwater harvesting, to think about that as a way of providing some water for our building, we can say yes. And then if we estimate, we can come up with some amount of gallons that we think we can produce a year, what the cost savings is, but we're also going to start getting this notion of really how much we're saving and really what it's going to qualify for some LEED credits in terms of doing that. So within here, there's lots of different options in terms of, just turning on either high efficiency or waterless fixtures, high efficiency toilet, like a low flow toilet there. Okay, or even saying that you want to turn on like a gray water reclamation system. So we can start to very quickly sort of figure out what the estimated impact is of doing some of these things and really ultimately how much that's going to try and save us. So just a lot of different things. Although kind of an interesting insight here, if I look at a gray water reclamation system versus a rainwater harvesting system, I can capture over 10 times as much by using rainwater as opposed to doing gray water. So as we think about it, one of those may be a more efficient or economical way to do it. So if we can, like rainwater looks pretty attractive in this place relative to the amount of rainfall that's happening here. Okay, so let us go ahead. We are going to adjourn from today, but what we are going to do is, as we shift into Thursday, we're going to move into actually designing plumbing systems and kind of thinking about the whole water side of the building and look at how we do that standardly. How as we put together systems, we can use the same sort of like duct sizing calculators to actually size pipes, because it's the same basic principle as you tie things together and you have lots of different uses. The flow, the total amount of flow ultimately determines how big the pipes will be. But then say, given this kind of feedback, really, how would we go ahead and design a rainwater harvesting system? What sort of components would be there and how we would route it in? Or if we were doing a gray water system, what would that look like? Okay, so we're going to push ahead into thinking about sort of plumbing systems and alternative strategies for providing water and really how you'd model them. Okay, so that's where we're going next. So let us break for today. Any guidelines in terms of check-ins and what's happening from your guys' side? Have most people checked in for the latest round?
Most people, I think about 75 to 80% of the people. Some of them said that they were busy with workload, so
sure.
We asked them to check in this week.
Excellent. So if you haven't checked in like last week, please go ahead and let us know so we can kind of check in with you this week. We're trying to make sure everything's moving along. We only got about like 2 more weeks left. It's really coming up really, really quickly. So let's just kind of check in with everyone, make sure that things are moving nicely, and if you're stuck on something that will give you some help to get through it. So don't just save it to the end. But go ahead and check in and let us give you some help. Okay, let us break for tonight.